when we talk about aging, I know that there are a number of theories as to why we age, what impacts aging, and how it does evolve. What are some of the more, let's say, reputable and functional theories on aging?
Oh, there's several. One is known as the free radical theory of aging. Free radical refers to an oxygen molecule that's very highly reactive to tissues, and our bodies produce these naturally, and over the course of years and years and years of life, our bodies lose the capacity to kind of control these very destructive molecules that they make, and basically these oxygen species to start to damage tissues and organs. There's theories where there's a wear and tear theory, and that's kind of obvious what it is. What the theory is, it's the more you use the tissues and the organs, they tend just to wear out just from use. There's genetic theories where there's a slow progressive damage to DNA over time, and our bodies can repair that, but as we get older, the damage isn't repaired, and then these damaged DNA may lead to deficiencies of immune systems and maybe susceptibility to infection or cancer, or the inability to repair tissues. So blood vessels are not repaired, blood supply to organs deteriorate, and that's part of the aging process. So there are all sorts of theories. One unifying mechanism of aging seems to be this concept of inflammation. So this was on the cover of Time magazine or all the news magazines like several years ago about the fire within, the silent fire within. You can't feel this. Everyone sort of knows what inflammation is. If you hit your knee, it swells up and it hurts, it's painful. Well, that's a large area of inflammation. But what it appears is that in the body, in the blood vessels, in the tissues, organs, brain, there is a micro version of that. There is inflammation of the tissues noted by certain chemicals appearing, certain chemicals called cytokines, tumor necrosis factors. It's kind of esoteric biochemicals, but what's happening at the microscopic level is like an uncontrolled fire, essentially, and that fire is damaging tissue. So this concept of inflammation actually explains many of the chronic diseases of aging. So if you look at the relationship between diabetes, cataracts, hypertension, congestive heart failure, all of these are conditions associated with increased markers of body inflammation. There's many more. Alzheimer's disease is an example of this. So we seem to also feel that aging does involve this process known as inflammation. You can get certain tests that will monitor or will pick up inflammation, but it's something you really can't feel. And so that's another concept.
And it's an interesting concept. Really, when you think about inflammation, you think about what happens when there's some damage. For instance, I think about a pneumonia, or I think about an arthritic knee, where you have white blood cells coming to clean up debris, but when it cleans up debris, still irritating enzymes leak out, which then create a little bit more blood flow, make it warm and red necessarily, then bring more white cells in to clean up some of that debris. But that inflammation is checked. It's more or less responsive to the environment. When it becomes unbridled, when it becomes uncontrollable, and you have progressive and continuing inflammation, you get an overreaction that doesn't know how to stop, and you start to get damage to organs. I think that's a pretty neat concept that certainly falls into place. But a lot of those concepts seem to all overlap. I mean, if you don't have the repair mechanisms in your DNA anymore, and we've heard about telomeres, which are that part of our DNA that repair the DNA, that keep it from degenerating to the point where that's not functional anymore to make new proteins or to replicate cells so that they could be functional and persevere for longer periods of time. All that will then end up creating an inability to respond to certain stressors. Antioxidants,